and we're going to look at the composition of functions, or composing functions. Now, if you think of composing, or at least when I think of composing, I think of music. So what do we do to compose music? Is we take a bunch of random notes, we put them together, we synthesize them, we do whatever we need to do, and we create beautiful music, or sometimes we create rap music. But that's what we're doing when we're composing functions. So we're just going to compose by putting things together. So when we have two functions, one function is just substituted into the other. So that's what we're doing, is we're taking a function and we're composing it or putting it into the other function. So if we have this function g of x, and if g of x is substituted into f of x, this is the notation we use. F of g of x, and we have to be very careful here. This dot is an open dot. The open dot compared to the closed dot of multiplication means something completely different. So we have to be very careful, because this f of g of x is not the same as f dot g of x. That's what we looked at back when we looked at the algebra functions. So those are definitely not the same thing. This is a whole new operation. And how this is read is f of g of x. So anytime you see this, it's f of g of x. What does that mean? Well, here's what it really means down here. We take the function g of x and we put it into f of x. So both of these notations are used. We have f of g of x, and all that means is everywhere there's an x in f, we replace it with another function. So this is the composition of functions. This is composing functions together. So let's look at one. Let's look at this example here. So now what we're going to do is we're going to do f of g of x. And it's a very good habit to get into, writing this as f of g of x. So what does that mean? Well, we go to the function f of x, and everywhere there's an x, we're going to replace it with g of x. And the first one, I'm going to do this a little bit longer just to show you what we're doing. So this equals 2, and remember, wherever there's an x, we're going to replace it with g of x plus 1. So there's the composition. But now what is g of x? Well, we go back up and we say, well, g of x, of course, is just x squared minus 5x plus 2. And that number 1 has to come along for the ride. We haven't done anything to it. At this point, now it's just multiplication. We just distribute that 2 in. So we're going to get 2x squared minus 10x plus 4, and again that 1's going to come along for the ride, and when it's all said and done, we're going to get 2x squared minus 10x plus 5. So that's f of g of x. Now let's look at doing g of f of x. Now this one's different, because remember, this is everywhere there's now an x in g, we replace it with f of x. So this one's going to look a little bit different here. So again, I'm going to do this the long way. So we're going to say f of x is going to go in for x, and we're going to square that. Minus 5 times f of x plus 2. So what's f of x? Well, f of x in this case is x minus, or 2x plus 1 minus 5 times 2x plus 1. And I hope everyone's noticed that I forgot to bring along that squared. That first one should be 2x plus 1 squared plus 2. 2x plus 1, when we square that, that's just the same as 2x plus 1 times 2x plus 1. We're going to minus and I'm just going to distribute this in right now, 10x minus 5 plus 2. So now we can expand this out, and we're going to get 4x squared plus 2x plus 2x plus 1 minus 10x minus 3. Just combine that negative 5 and that 2 together. And then the last step is combine all the like terms, and we're going to get 4x squared minus 6x, because we have 2x and 2x is 4x minus 10x is minus 6x. And then we have 1 minus 3, which is negative 2. And there is g of f of x. Now, what I want to do is I want to look back for a second, because f of g of x was 2x squared minus 10x plus 5. G of f of x is 4x squared minus 6x minus 2. What can we conclude? The order matters. This is a very important point. The order matters. If we don't use the proper order, you're not going to get the same solution. So when we look at that, what matters? Order matters. So if we have g of f of x, remember we write that as wherever there's an wherever there's an x in g, we replace it with f of x. And f of g of x is where there's a x in f, we replace it with g of x. And looking at that last example, we can come to this conclusion, that f of g of x is not equal to g of f of x. So you have to make sure we're doing that in the proper order. Very, very important point. So let's look at this example. Let's compose this. Now, the thing that's different about this one is now we have not just an x value, we have a numerical value. And what I'm going to do is I'm going to show you how we can do this to make it a little bit easier on ourselves. So remember, f of g of 3 is just the same as f of g of 3. So if we're replacing this, what we're going to do is we're first going to go to the function f, and we're going to replace the x with x squared plus 2x plus 3, and we're going to minus 3. And if we expand that out, we're going to get negative 4x squared minus 8x minus 12 minus 3, and we're going to get negative 4x squared minus 8x minus 15. And now what we can do is we can put, wherever there's an x, we can put the 3. So we're going to get minus 4 times 3 squared minus 8 times 3 minus 15. And we're going to get negative 4 times 9 minus 24 minus 15. So we're going to get negative 36 minus 39, which is going to equal negative 75. Perfectly legit. We can do it that way. There's nothing wrong with doing it that way, but there's quite a few steps to doing it that way. I'm going to show you another way that we can do this. We can, right from the start, find out what g of 3 is. So let's just figure out what g of 3 is, because we know we're going to replace that value in f. So g of 3 is just going to become 3 squared plus 2 times 3 plus 3, which is going to become 9 plus 6 plus 3, which is 18. Now what we can do is we can take that value, which is g of 3, and we can replace it in the function f. So everywhere that there's an x and f, we can replace it with this numerical value of 18. That's all we're going to do. So we're going to go, and now we're going to find out what is f of 18. Well, we just plug that in. Negative 4 times 18 minus 3. Negative 4 times 18 is negative 72. Minus 3, we get negative 75. And as you can see, you get the exact same answer. So either solution will work fine. We get the exact same answer both ways. I think it's easier to do it the second way than it is to do the first way, but there's no reason you can't do it either way to get the same answer.